Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous topic we have discussed about the geometrical isomerisms in the metal complex with the coordination number of 4. So now in this topic I am going to talk about the geometrical isomerisms in the metal complex with the coordination number of 6. So what are the different isomers? That is what we could observe in this complex compound. So let me talk about that in this topic. So friends, I'm going to talk about the geometrical isomerism in metal complex with a coordination number of 6. So in this case, the complex that are been formed, they have a geometry of octahedron. The reason behind that is, we can find that is there are 4 ligands that will be in a square planar, while the rest of the 2 they will be they will form bipyramidal structure. Therefore, it will form a structure of a regular octahedron. So based on that, what are the different classification, or what are the different complex, that is what we could find with the coordination number of 6. Even this is what we are going to talk about with the help of a geometrical isomerism also. So talking about the first type, that is so friends, suppose if we are talking about the first type, that is MA4B2. In this case, the A and B, they both are different to each other whenever we are talking about ligands, and in this case A and B, they are known as monodentate ligands. And in this case, there is 4 molecules of A and 2 molecules of B that are been associated with the central metal atom. In this case, it is M, where the N, that is, it represents the number of positive or the number of negative charge on the complex ion. Suppose if I am talking about an example where we can find that is the platinum is present at the centermost, where talking about the rest of the 4 ligands that are basically in a square planar, that is NH3. Here also it is NH3. Here it is NH3. And if you see the formula, that means there will be 4 molecules of NH3 over here. So therefore I could write this another molecule of NH3 here, and suppose if this is Cl and this is Cl. So in this case, basically we can find that is this NH3, this Cl, this NH3, they are present in a square planar, while this Cl is above the plane and this NH3 is below the plane, making a overall structure of that is octahedron. So this is the complex, that is what I have mentioned. But talking about the another complex based on this same formula, that is I could write it as, where the platinum which is present at the center, this is NH3. Here also there is NH3. That is, all the NH3 groups, they are on the square planar, while here we see there is Cl, and on the below the plane also there is Cl atom. So in this case, if I would write the structure, again it is a octahedral structure. But what is the difference between these two? I can find that is this Cl is in adjacent to this Cl, as you can see, that is, and in this case basically I could find that is the difference, where I can find that is there are 3 NH3 that are on the plane, while one of the Cl which is on the plane and which is very much adjacent to this Cl. While if I talk about this one, so I could find that is all the NH3 they are on the plane, but this Cl is opposite to this Cl, making this complex to be called as trans complex, and this one would be called as cis complex or cis isomer. So therefore this was the first type, and now let me talk about the second one. So the next one, that is what we have is a type of Ma3B3 N plus N minus. So here basically we can find that is there are 3 molecules of A ligand and 3 molecules of B ligand. So in that case, suppose if I am talking about an example where suppose if platinum is present at the centermost, and suppose in this case there are 3 molecules of NH3 and those have a position that is here NH3, NH3, and suppose here there is Cl and here there is Cl, and above the plane there is Cl and below the plane there is NH3. So therefore this is nothing but it is following the same formula, that is Ma3B3. But based on that I could write the another formula, that is another structure depending on this, that is platinum, where I could find Cl is here, one Cl is here, this is NH3, here also there is NH3, here there is NH3, and in this case suppose here there is Cl. So what is the difference between these two? Let me explain you. Here basically this 4 are that is on the plane, even here this 4 are on the plane, but among these two, which one would be called as cis and which one would be called as trans? So here I can see that is chlorine is, suppose if it is present at first position, and suppose if this is second, third. that is first chlorine, second chlorine, and third chlorine. And in that case, basically I could find that is their position is in clockwise, that is from 1, 2, and 3. So here we can find that is this 3 are adjacent to each other. So this is chlorine number 1, this is chlorine number 2, or position number 1, position number 2, 3, 4, 5, and this one would be 6. So I could find that is this 2 chlorine atoms, they are adjacent to each other, while this is the 6th position, and here basically I can find that is this Cl and this Cl, they are opposite to each other. So therefore this one would be called as cis, while this one would be called as trans. But not only this, they have the other name also. For example, here I could find that is there are 3 Cl, that is atoms that are adjacent to each other depending on the position also, that is this is position number 1, this is 2, and this is 3. So this adjacent position and this consecutive position, that is what we could get, will give the name of this one as facial, or we could also call it as FAC. While in this case the name of this one would be, that is meridional, which is also known as MER. So therefore these are the 2 different kinds of isomers, that is what we have discussed about. And now let me talk about the next one. So based on that, let me give you an example. That is, suppose if I'm talking about a complex where cobalt is present at the center, and suppose if it has been surrounded by 2 ethylene molecules, and that is I'm writing over here, because ethylene approaches with the help of the nitrogen, and that's the reason it forms a ring structure to the central metal atom. And talking about the another ethylene molecule, so therefore ethylene diamine. And talking about the other 2, that is monodental ligands, so in this case it is Cl, suppose. So this is basically a structure, that is what I have mentioned over here. And now let me talk about the other isomer of this one. So where cobalt, it will be in the center. So this Cl and this Cl, they will be opposite to each other. And here basically there will be an approachment of the ethylene diamine, which forms a ring structure with the metal, that is cobalt. So therefore these are the 2 structures, that is what I have mentioned over here. But which one would be called as cis and which one would be called as trans? So here basically I could find that is the Cl and this Cl, they are adjacent to each other, and that's the reason they are called to be cis. And even the ethylene diamine, they are adjacent to each other. But here the ethylene diamides are opposite to each other, and the Cl is also opposite to each other, and that's the reason it is known as trans. This were the geometrical isomers in metal complex with a coordination number of 6, and that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.